Hello everyone. Today we are going to look at number system and how to handle that in Python. So the number system that we have been using, or we say integers, let us make integers, right? So the number system that we are using is the decimal system, right? So what we have, so we use 0, 1, 2, 3, all the digits up to 9, right? So if we count it, I have totally 10 digits here. So that is called, we call that the base of the system. Okay, here base is 10. So now we don't have to, for example, use 10 digits. For example, I can just use the 0 and 1. So now my base will be base is what in this case it will be 2, right? And this is a binary system. So how do we do this thing? So I can just say, I start with, say, my decimal system, 0 is 0, I can say 1 is 1, and we do the same thing. Like suppose I have 2, now I can go same thing, like after 9 we do 1 and 0, same thing here, but that is represented by 2. Now 3 will be, I add 1 to that, it is 1 1, and 4, for example, 1 plus 1 0, 1 plus 1 0, and I have 1 carry, and 5 will be 1 0 1, and 6 will be so and so forth, right? So now this is my decimal system, and this is my binary numbers, right? I am just using 0 and 1. So now if you look at how to, for example, I give a number, I suppose I want to come back and find this guy. It's very simple. So we know that, for example, if I tell you 25 in decimal system, what does it mean? I usually say 2 into, I have 110, right, to the power of 1. The first position is basically 10 to the power of 0 or 1. So which is 20 plus 5, 25. If I have like 367, what is it? So I'll say 3 into 10 to the power of 2, 0, 1, 2, like that. And 6 into 10 raised to the power of 1 plus 7 into 10 to the power of 0, right? 7 plus 60 plus 300. So that is the idea. So similarly, now I can use that here, but the thing is, this is the base is 10, right? In this case base is 2, so we'll consider powers of 2. So 0 1 2, so and base is 2, so this is my binary system. So I take 1 into 2 to the power of 2 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 0, right? So which is basically 4 plus 0 plus 1, and which is 5, and this is in my decimal system, right? So that's what we have here, right? So similarly, if I want to suppose, for example, I want to find what is 6, right? Now I can keep on writing like that and say add one more 1 0, right? This is 6. Or suppose if I ask you, I want to convert from this to here, I can just factorize, and like, you know, I can say 2 3 times. So and my remainder is 0, 2, 1 time I have 1 is my remainder, and what is remaining is the 1. So this 1 1 0, I read from bottom to up, so that is this guy. So we can convert back and forth. So similarly, not only like binary system, we also have other systems in use. For example, we can, for example, we have octal system, and we also have hexadecimal system, which we will be using. For example, in say if you look at octal system, we have, as the name indicates, 0 1 2 up to 7, so that we have 8 digits. And in hexadecimal system, for example, we have 0, we have 1 2 3 up to 9, and after that we already used the 10, so we need up to hexadecimal is 16, right? The base is 16 here, and this is base 8. Okay, So I'll use A for 11, B for 12, and 15 will be F. So 15 plus 1 here, so that is a 16, the hexadecimal number. And so the conversion and all the ideas that I previously told applies. For example, if you have something like 1F in hexadecimal system, so you will say, right, 1 into 16 to the power of 1, right? And F is basically, this is 15, right? So 15 times 16 to the power of 0. So I have 16 plus 15, which is 31. So this is my 16 base number and corresponding and decimal number, right? So the back and forth is similarly easy. You can convert back and forth. So we'll be mostly coming back and forth between hexadecimal and the binary system. We'll see more in our other discussions. So now let us see how to handle all these things in say Python, right? Very simple and straightforward. So suppose if I want to write a simple binary number, right? Binary number, say B, let's keep it simple, B. I'll just say 0 and I'll put a B, and if I want to write say 1 0 1, so that is my B. And if I want to see what it is, I can just ask B. So it's 5, you know. So another example, for example, we know 1 0 1 and B is now 6. So this is, so you can put, you don't have to like view so much less, you can ask, you can put, you know, bigger numbers. So now similarly we have the octal numbers, for example O, right? For example, I can say suppose if I take I'll say 0 and O, okay, small o, and then say 1771, and I say O, we correspond, that is the actual decimal number. So octal number, this octal number correspond to this in decimal number. And we have also x numbers, right? And suppose if I say C equal to, I'll write the way 0x 1 F, for example, right? We already saw that is 31. So now this is from by how to represent a binary and octal hexadecimal number in Python. While you actually type it, you can, you know, directly write it up, assign to a variable. Now if you have an hexadecimal number, suppose if you have a binary number, decimal number like 31, and how to say convert to a binary number. I want to look at, for example, say if I want to look at something like, say I have 100, I want to convert into binary, I just say bin 100. So that is the value. And similarly we have octal numbers or CT. I can say, for example, write of 32 in this in is 0 or 4, basically 40 is the octal representation. And similarly hexagonal, you might have guessed, it is say 32. Suppose 32 in, or we can write in what we have done earlier is so 32 in, or you can write in a bigger number, okay? So corresponding to 1222, if you convert that into hexadecimal number, that is 1. And if you want, like, you know, so this is the one we already tried, 31. So this is very simple and easy. So we have seen how to represent number systems like hexadecimal and octal in Python, and we also know how to convert them back. And if I give you a decimal number, we know how to convert it into a corresponding by a binary or octal or hexadecimal representation. And thank you very much for watching.